Standard deviation is one of the risk analysis techniques. So it measures the risk associated with the project cash flows. Project cash flows are estimated ones, and estimated ones cannot be accurate, and there can be a margin of error. The risk associated with the project can be expressed as the extent to which the actual value of outcome will differ or deviate from the expected value. Say, for example, if you are expecting 10,000, so it may not be possible to get the 10,000 in the month end. It may deviate from the expected value. So, that deviation, how much will be the deviation? So, it measures. This risk is measured with the help of a statistical tool known as standard deviation. Standard deviation is a standardized unit of a deviation from mean. Deviation from mean. This measure is denoted by the symbol, this one, standard deviation. The square of standard deviation is known as variance of distribution. So higher the standard deviation, higher will be the risk involved in the project. So how to compute this standard deviation? Following steps are involved in the computation of standard deviation. First one, compute the expected values. Second one, compute deviation from the expected values. How much it is deviated. Third one, add aggregate result of step 2. Aggregate result of step 2. In the sense, we have to add all the aggregate results. The resultant value is known as variance. Find out standard deviation by using this formula. So, root of variance is the standard deviation. Variance meaning. Variance is a measurement of the degree of dispersion between numbers in a data set from its average. In very simple words, variance is the measurement of difference between averages of the data sets from every number of the data set. So this symbol is the where standard deviation is variance in the net cash flow. P is the probability, ENCF expected net cash flows. So this is the formula. Anyhow, we'll go with the example, then you will understand clearly how to calculate it. So variance measures the uncertainty of the value from its average. So how much variance is there? Say for example, a small variance would indicate cash flow would be somewhat stable. Small variance. So it is deviated from the averages. Okay, it is deviated from the averages in the sense we are if we are expecting 10,000, so small variance, if small variance is there in the sense we are getting 9,500, 9,600. So it is very close to the expected ones. Not exactly, it is very close to the expected one. So cash flows would be somewhat stable throughout the life of the project. If zero variance is there, in the sense whatever you are expecting, you are getting the same. See, variance value of zero, it indicates the cash flows that would be generated over the life of the project would be the same. Say whatever you are expecting, those are coming. So is there such kind of situation? Yes, this might happen in a case where the company has entered into a contract of providing services. So in such a case, obviously they will get the return by providing services. So these are on payment services already entered into a contract. So in the small variance case, this is possible in case of products which already have an established market. So in any condition, in any situation, they will get the some stable cash flows. Say for example, um, soaps, bath soaps. So in any condition, people are using the bath soap, different kind of a whatever the company may be. It has its own market. So it is irrelevant that whether the market is supporting or not. So somewhat they are getting the same stable cash flows. Large variance, it indicates there will be a large variability between cash flows of the different years. This can happen in case where the project being undertaken in very innovative and would require a certain time framework to market the product. So it is an innovative product and it still needs the placement in the market. So in such a case, even though they are expecting, it deviates with the reality ones. So that is the error we have to eliminate. So another one is coefficient variation. This is also very useful technique to reduce the to identify to measure the risk. The standard deviation is a useful measure of calculating the risk associated with the estimated cash flows from an investment. The thing we just read. So, however, in capital budgeting decision, management in several times faced with the choosing between many investment possibilities. So, in capital budgeting decisions, management obviously many times they have to face this kind of a proposals, investment proposals. Under such situation, it becomes difficult for the management to compare the risk associated with a different project using the standard deviation, as each project has different estimated cash values. In such a cases, coefficient variation becomes useful. The coefficient variation calculates the risk borne for every percent of expected return. It is calculated as coefficient variation is equal to standard deviation by expected returns. Standard deviation by expected returns or expected cash flows. So higher the coefficient variation, higher will be the risk involved. The same as with the standard deviation. Higher the standard deviation, see, higher the standard deviation, higher will be the risk involved. Okay, so let us go with the illustration. So illustration 2, project A and project B. These are the possible events A, B, C, D, E. And for project A, cash flows and the probability, project B, cash flows and the respective probabilities. As I told you, if you count all these things, so total will be 1. Let us see. 1 plus 2, 3 plus 4, 7. 7 plus 3, 10. Here also 10, 15, 25, 75, 75 plus 90, 100. So it is also 1. So probability always will be 1. So calculate the variance, standard deviation and the coefficient variance for the project based on the above information. Which project is more risky? So let us solve this problem. First step is we have to calculate the expected values, expected cash flows. So calculate the expected cash flows. Statement showing the calculation of expected cash flows. So I'm just considering all the values from the above illustration. Those are possible events and the cash flows of a project A and the probability of cash project A, and expected cash flows column is an empty. So cash flows of project B and their respective probabilities. So expected cash flows, how to calculate? We have to multiply the cash flows with the probability. So 8000 into 0.10, that is 800. So 10,000 into 0.2, 2000. 12,000 into 0.4, 4,800. And 14,000 into 0.20, 2,800. 16,000 into 0.10, 1,600. The total expected value, expected cash flows of project A is 12,000. So coming to the project B, expected cash flows 24,000 into 0.1, 2,400. And 0.15 into 20,000, 3,000. 0.50 into 16,000, 8,000. And 1,800. 8,000 into 0.1, 800. Total will be 16,000. Total expected cash flows for project B, 16,000. So now we have to calculate the variance. Variance, that is sigma square. Project A. Variance of possible event. Variance of possible event is equal to net cash flow minus total expected cash flows power 2 into probability. This is the formula for the variance possible event. So variance is nothing but sigma square. Okay. So net cash flows minus total expected cash flows power 2 into probability. So in this given table, I just represented this formula net cash flows minus total expected cash flows power 2 into probability. So cash flows, so total like expected cash flows, we have to deduct it and then again we have to square it. So we have to multiply with the probability. So finally variance will come. So cash flows, these are the cash flows, and total expected cash flows for project A. So that is 12,000 for each case, for each event. So net cash flows minus total expected cash flows. So that variance, so 8,000 minus 12,000, that is minus 4,000. Here minus 2,000. Here 0. Here 2,000. Here minus 4,000. Sorry, 4,000 positive. So A minus B, this is A minus B power 2. So 4,000 into 4,000, minus into minus plus, 4,000 into 4,000. So these are the calculations. We have to multiply with the probabilities, with the respective probabilities, so that we'll get the variance, that is 16 lakhs, 8 lakhs, 0, 8 lakhs again, 16 lakhs again. So total variance, that is sigma square, is 48 lakhs. Sigma square 48 lakhs. Now calculation of standard deviation. That is root of sigma root of variance.
So root of variance is equal to root of 48 lakhs. It comes around 2190. 2190.90. So by applying the same procedure, we have to calculate the standard deviation for the project B. Project B. So, I'm just taking the same values from the project B. Cash flows, probability, and total expected cash flow 16,000. So these are the cash flows, and total expected cash flows are 16,000 in each possible event, and probabilities. So let us calculate the total variance. Net cash flow minus total expected cash flows. That is 8,000 and 4,000. So 0 minus 4,000 and here also minus 8,000. Minus 8,000. So these are the values, and we have to multiply with the probabilities. Then we'll get 64 lakhs and 24 lakhs and 0, 24 lakhs again, 64 lakhs again. So total is 1 crore 76 lakhs. 1 crore 76 lakhs total variance sigma square. So the standard deviation is root of 1 crore 76 lakhs. So it comes around 4,195. So let us so we calculated the variance and standard deviation coefficient variation for the projects based on the above information. Okay, now we have to calculate the coefficient variation. Coefficient variation for the project A. Project A. So formula for this coefficient variation is standard deviation by expected return or expected cash flows. We calculated the expected cash flows and we know the standard deviation as well. So standard deviation divided by standard deviation by expected cash flows. So standard deviation, let us calculate the project B as well. So for project A, standard deviation is 2190.90 by expected cash flows 12,000. So 2190.90 1190.90 by 12,000. Here also standard deviation is 4195.23 by 16,000 of the expected cash flows. So it comes around 0.1565, and for the project B 0.231. So decision making in project A, risk per rupee of cash flow is 0.1565, while in project B 0.2331. Therefore, project A is better than project B. So higher the COV, higher will be the risk. Here also, higher the COV, higher will be the risk in project B. That is why project A should be selected because it has lower COV. Even in standard deviation also, project B has highest standard deviation when compared to the project A.